In this video, we'll be deriving some of the standard distributions. So we're talking about the characteristics function for the random variable, but for a continuous case. In this one, we are talking about the gamma distribution. So how do we derive that of the gamma distribution? For the characteristics function, for more on this topic, you need to subscribe to this channel. For the characteristics function, we have the expectation of PITX, which is, since it's a continuous case, we'll have integral from 0 to infinity PITX multiplied by f of x, then dx. So this is how we can derive that of the gamma distribution. So we move over to this other side of the board. It then means that our characteristics function for the gamma distribution can be written as the integral from 0 to infinity EITX. Now, multiply by the PDF, which is given as this. So we have beta multiplied by x multiplied by exponential function negative beta x all over the gamma function. So all we need to do is to bring out this 2, which is going to be the constant. So we'll have beta into the gamma function, integral of x is here, we have x, sorry, this is the x, minus 1, then multiplied by exponential negative delta x multiplied by exponential ITH. So since this 2 is common, we can do something here. So we have our characteristics function to be beta into the gamma function multiplied by the integral of x alpha minus 1 multiplied by exponential negative, okay, we can bring that x because x is common. So we have minus it, then x dx. Of course, the whole of this means something. So we have our characteristics function to be, the gamma function multiplied by the whole of this will give us the gamma all over beta minus it, then alpha. So the whole of this function will give us this. The next thing to do to get our characteristics function, here, the next thing to do, this can cancel this. So we can now write our characteristics function to be, we come over to this side. We can now write our characteristics function for the gamma distribution to be beta all over beta it, then alpha. So this is how we can derive the gamma distribution for the continuous case. So here we have the characteristics function for the gamma distribution to be this. For more on this topic, you need to subscribe to this